Okay, today we're going to talk about functions, and we have 3 lectures remaining. We have functions, we have libraries and packages, and then we have classes and object-oriented programming. So between these first 2 here, functions and libraries and packages, you should have everything you need to do assignment 2. And then assignment 3 focuses on classes and object-oriented programming. Let's see, wrong. Look up in here. Here we are. All right, so we're going to look at functions. Let me go into view mode here. We're going to look at functions, why we're using functions, how we create them, how we execute them in the code, what they're useful for, some features about them called parameters and arguments, what functions return to you, some return values, and then how variables are managed within functions and outside of functions, and we'll end with some best practices. So imagine you're building a shopping cart program which needs to perform a lot of different tasks, such as adding items and calculating the total and applying discounts and calculating taxes. If we didn't use something like functions, we would need to repeat the same block of code for these tasks, for every single thing that we needed to do. So I have an example in here. So recall from our earlier lectures, we had made this shopping list and we said, hey, we're going to make a variable called milk and assign the value of milk to it. We're going to make a variable called eggs and assign the value of eggs. And we're going to do this for all of these things. And we talked about how we could print each of these items, or we could create something like a list and then just print the list and update the list. Well, imagine we want to build on this, and now we actually we're evolving this shopping cart from our lecture about lists, and we want to track the price for each item and the name. So we decide to use something called a dictionary. We tried to use this dictionary object that we talked about. So we're going to create a dictionary called shopping cart. It's called shopping_cart equals, and then our empty dictionary here. And at the value of laptop, we're going to set that equal to $1,200. So if we run this piece of code here, might need just a minute to connect to my resource. We see that we have a dictionary with one key value pair. The key is laptop and the value is $1,200. And we want to continue to add items to this list. And we learned about dictionaries, and we know that we can just continue to manually add items to this list if we want to. We can add more key value pairs. We can add headphones for a price of $200. We can add mouse for a price of $50. But there's a lot of potential to introduce error here. There's a potential that we could make typos here, and we see that we're doing the same code over and over again. And so we want to use some type of framework to enhance our code, to enforce some consistency in the way that we add an item to the shopping cart. So we can do something called creating a function. And this is a function here. We're saying def, which is how we declare a function, how we tell the program that we are now going to create a function. It's one of those keywords that are reserved. So def means the same thing to me as it does to you, to somebody else in anybody's code. It's a reserved keyword. Then we're going to say the name of our function, which we've decided to call add_item. You can call it whatever you want, just as we can call our variables whatever we want. And then we're going to pass some items to this function. We're going to pass a cart, we're going to pass an item, and a price. These are variables. We are creating a variable called cart within the realm of this function, a variable called item, and a variable called price. And then we're going to do some operations on them. You can see that this operation, cart at item equals price, is exactly the same operation that we were doing up here, shopping cart at headphones, shopping cart at laptop, but we just generalized it. We said shopping cart at, well, a laptop and headphones and mouse, those are all items. So each time we want to add something to the dictionary, we're going to pass the name of the item that we want to use. So this one line of code here, cart at item equals price, replaces these 3 lines of code. Then we're going to print just to validate that we've indeed added this item to our shopping cart. And then we're going to call this function 3 times. We're going to call the add item function and pass in the cart. We're passing in our dictionary called shopping cart. We're passing that, and that becomes cart inside of the add item. Then we're passing our item. That becomes item inside of this function. Then we're passing 1200 here. That becomes price inside of this function. So cart is equivalent to shopping cart at laptop is equal to 1200 when we call this line here. So we build functions. We built this function, and the utility is not just in this one function. Functions will really allow us to break down things like an entire shopping cart system into reusable components, into these components like add item, and then we can create other components. We can create calculate total. We can create apply discount. We can create all of these defined units of code that execute operations for us and have roles and responsibilities that are individual within our program. And then we can interact with these functions to have a fully operating program that's really broken down into manageable components. So what is a function? I know we kind of went through a whole example here to understand where we're getting to, but we're going to break this down piece by piece here. Functions are reusable. Make this smaller here. Functions are reusable blocks of code that are really designed to perform a specific task. They can help us simplify problems by breaking them down into smaller, more manageable parts. So imagine this function add. Let's do that one. Def add AB, return A plus B. Let's just call add 3, 4. You know what? I'm going to do that on a totally separate line, actually. Okay, so let's create a function. For example, when we add things in Python, we have 3 plus 4. We add 2 things together, we get the output of 7. We can make a function that has the same property that this operator is having on these 2 numbers here. We can create a function called add. So def is our keyword here, and the name of our function is add. Add accepts 2 parameters. Add accepts A and B, and it returns A plus B. So here we can call our add function by using the open parentheses and the 2 values that we are passing to the A and B argument parameters here. 3 gets assigned to A and 4 gets assigned to B. Then when we call this function, 3 and 4 get added together, and we return the result of that, which is 7. So functions like this can imagine, adding a number is probably something that you do quite a bit in your code. It's a very useful function. It's something that you're going to use over and over and over again. And maybe you don't want to, there's more complexities in here, and you don't want to code all of that every time you want to use it. You want to have one piece of reusable code that you can plug and play into lots of your work. So it helps us avoid repetition, and it really simplifies complex programs into smaller units, which are actually easier to test. They're easier to debug. They're a lot easier to support, to maintain, to swap out, to fix, to refactor. So functions are quite important in Python and in programming. You've already maybe done a few of these things, adding two numbers together. We calculated some formulas in our first assignment to calculate interest. As you move on more and you start scoring the performance of a machine learning model, in sklearn, all of their scoring functions all of their scoring utilities are functions. So all of those are functions. These are very robustly used throughout Python and programming. So a couple benefits, of course, are the reusability, the modularity, the readability, and the maintainability of your code. Let's start looking at how to create and use these functions. I'm going to introduce two terms here, which is defining, or the definition of a function, and calling the functions. So in Python, a function is a block of code that is defined with a name. So we have this presenter view here. So we have this def keyword here, and this def keyword, it indicates that it is the function definition. It indicates to the program that we are going to create something called a function definition, and a function definition just sets the code for what a function is. So this code, when we create this function definition, it isn't actually executed. It's stored in the memory of the program, but it is not executed. So if you're adding numbers in here, or if you're doing other operations, those are not executed until you do something called calling the function. So the block of code is only executed when the function is called. This is a call to the function. To call the function name, we simply say the function name followed by the open parentheses, close parentheses, and then within those parentheses, if there are any parameters, we pass them. So inside of this function definition here, the first line, there we are. The first line of this function definition is the header. So that is this section here is the header of the function definition. The rest of this is the body of the function. So if somebody says, is this within the body of the function, or what's in your the body of your function, that is everything except the header here. The function name is a name that you choose for the function. It's what you choose to call the function. It has very similar structure and requirement to our variable naming. And then anything inside of these open parentheses are parameters that you are asking for to be passed to your function when somebody is calling it. So they are things that you need in order for that operation to occur. So if we're adding two numbers together, we cannot add two numbers without two numbers to add. We need A and B in order to add two numbers to each other. So again, we have the keyword here, the function name, the parameters, the body of the statement, and then we have the function return. The function return is what is given back to the user at the end of the statement call. So when we call a function, we call it by using its name, just as you know, you might call a friend by using their name, or your pets by using their name. We do the same thing with functions. We create this function greet, def greet, and we're asking for the parameter name to be given to us. And then we can call this function simply by using its name, greet, and then open parentheses. And in this case, we are passing a parameter into the function because it is requesting a parameter called name. One thing to note is that the function definition does have to be executed before the function is called for the first time. I have an example of this in the notebook. But if we were to take this unit of code here and we were to move it down below and it was our first time running our notebook, we would get an error. We can look at that. So if we were, for example, to create this new function called def my new function, and it prints hello, if we tried to call the function before the function definition was actually stored into the code, then we would receive an error. So we can try that right now. We get a name error. Name, my new function is not defined because we're trying to call this function before we've told the program what the function definition is. So you must create the function definition before you try to create an instance of the function. Oh, I got ahead of myself. This is a exercise for you guys. We'll move through the exercises today. I won't pause and ask questions, but if you're watching the recording, pause and think about these. And how would you fix this issue that we just talked about? Again, pause on the recording and try this. You try it. We're going to keep going here because we have a small class today. So in this, you try it. Define a function that prints this as a function, and just try calling that function. Start working with functions here because they're going to be really important, both for understanding your second assignment, but even more so when you complete your third assignment. All right, so function parameters and arguments. One of the benefits of creating a function is so that we can use it in a very dynamic manner. If it does something very specific for a particular task, that can be useful. However, a lot of the utility of functions is that we can generalize them and use them across multiple code bases and multiple purposes. And you've actually been working with functions in Python for quite some time now. Every time you run type on something, you run type, open parentheses, 1, 2, 3, close parentheses, that is a function. And that is why type actually has that syntax of open parentheses and close parentheses, because it is a function call that you are calling, and it is returning to you in its return statement the type of that data type that you are working with. Similarly, type conversion, you've been using these functions built into Python, calling int on 32, casting that from a string to an integer is a function. And some of these functions, these are just examples of ones that take one argument. Of course, functions can take many arguments. We saw the function that we created with add took in A and B, so it can take in multiple arguments. And these arguments are assigned to variables, which we're going to call parameters. And this is what enables functions to really operate dynamically. It wouldn't be very useful to us if math.sign only ever worked on the value 0.7. We want math.sign to work on all of the numbers that we potentially want it to work for. So the value of parameters is that we can pass in a particular piece of data, a particular piece of information, and the function can dynamically use that in its program to return you the answer that you want, to provide you that functionality such as math.sign. As far as parameters, let's take a look at those. Parameters enable our functions to take in data. So parameter is the variable defined inside of the function definition. Let me color that. This is the variable. So the variable is name. The name is what we are using right here in the print statement when we're saying print hello name. And this function assigns whatever arguments are passed to it when the function is called. And we'll talk about arguments right now so that this makes sense. So when we call the function, when we call greet, and we open parentheses and pass in some information, this is the argument. So we can pass in data known as arguments to the function. These are the values that we pass to the function when we call it. These arguments become parameters. So the arguments, they get assigned to parameters in the function. So in this one, this was the parameter. In this case, Alice is getting assigned to the parameter of name. This is essentially saying, I meant to write name first. This is essentially saying name maybe I should have done this in the name equals, I'm not going to write the whole thing out here, but Alice, right? Dot, dot, dot. Except that it doesn't just always equal Alice. It equals whatever value that we pass to it from the argument. So it can be Alice this time. Next time it can be Bob, or it can be Julie. So when we pass Alice as an argument to this function, greet, it gets passed as the parameter name. Name takes on the value of Alice for this function call. For this one function call, name takes on the value of Alice. A little thing to know, I'm going to exit out of this, jump to the notebook real quick for a moment. Let's look at that. Okay, so we have this function, def greet, that has this parameter name. We're going to call greet Alice. And when we call greet Alice, you see that this code gets executed. Print hello name. In this case, it says print Alice. But we can make this name print Emily, greet Emily. It'll say hello Emily. We can say greet student 1, 2, 3, 4, 5. And it will say hello student 1, 2, 3, 4, 5. So this function, it's very dynamic. It takes in this parameter, and the output, what we get from our function, the operations that it performs, changes based on the parameter that we are giving it. Variables can also be passed as arguments. So in this case, I was passing these string values. We can actually abstract that, and we can pass variables as well. So let's create a variable called myVar. This variable is called Bob. Let's call greet Bob, greet with myVar, and we can see that it says hello Bob. So what is happening here is we're calling greet. Greet is going to this function. It's saying my name is equal to myVar, but myVar is equal to Bob, so thus my name is equal to Bob, and printing out hello Bob. When we define a function in this way, when we say, hey, def, let's create greet, and we define this parameter name, the function, we must always pass a name when we call the function. So for example, if we create this, let's just recreate this. We don't need to recreate, there we are. Let's just call greet, but not pass any name at all. What happens if we don't pass a name? Well, we get an argument, we get an error. It says greet is missing one positional argument, and that positional argument is titled name. The error that they're giving us is trying to help us understand that we cannot call this function without passing in a argument to be assigned to the parameter of name, that positional argument. So if a parameter exists, you must pass an argument. If you're in a situation where you want to be able to call the greet function and it to have some functionality when you do not pass a parameter and not to just throw an error, you want it to say something like hello guest. If you don't know somebody's name, you can leverage something in Python called default parameters. So we can say def greet name is equal to guessed, when you put the equal sign inside of this parameter definition and you give it a value, you're doing something called creating a default parameter. You're telling the program that when we call this function with no parameters, by default, I want you to use the value that is here, that I am defining here in this function definition. So up here, we saw that we got an error with our original function definition where name did not have a default value. But down here, we gave name a default value. And so we can call greet without passing a parameter. I would like you all watching the recording to pause for a moment and try this you try it exercise here. Write a function called meal cost with 3 parameters: price, tip price, and tax percentage, and then calculate the total cost using this formula on the slide and return total cost. Then maybe try testing your function, try adding some default arguments, and there's a bonus challenge there if you want to try that. I would spend maybe 5 to 10 minutes on that. Let's talk about return values. Sometimes we develop functions and we don't need any value back from them. We just want them to perform some operations. But other times we want information back. So when we are adding 2 numbers together, when we're adding 3 and 4 together, we want to know what the result of that operation is. We want to know that the result is 7. So how do we get information back from functions? How does our code communicate with the function to retrieve information back? There is a keyword in Python called the return statement. So functions can return results of all these operations that they are executing to the caller with this blue keyword here called the return function. So in our add function, we said return a plus b, and it returns the results of 7. So that data, when we say result is equal to add 3 plus 4, what happens in the code is the program says, oh, add 3 plus 4. Let's go look at the add function, pass the value of 3 to A, pass the value of 4 to B, add 3 plus 4, that is 7, then return that value. So we send it back to here. 7 gets stored into result. So what is stored into the variable result is not add 3 plus 4, but actually the result of 7. Functions in Python do not have to return something, and implicitly, if you do not have a return statement, the function will actually return none. I should take just a moment to talk about what the none type object is in Python. In Python, the none type object is a special built-in constant that represents an absolute value or the absence of a value or a null value. So this is the null data type for Python. So if you're familiar with SQL, you might be familiar with the null data type. The equivalent of that in Python is none. So it is an object, it's its very own none type data object, and it's commonly used when you either want to do nothing or there's no value, or in the case of our function example here in the bottom right-hand corner, def greet, print hello everyone. If we called greet and then tried to assign the results of that value back to something, assign it back to result, when we print result, what we're actually going to get is none, because we have no return value from this function defined in this function. We have no return. So by default, functions will return none. Go ahead and pause for another 5 minutes or so. Give this you try it a shot. the variables that we define within functions are not necessarily designed to be used throughout the whole program. So now we have to think about something called scope. What parts of the program have purview or access to certain variables, and what parts of the program do not? So we're going to talk about local and global variables. Local scope is when you create variables inside a function. And when we do this, it actually only exists inside of the function. So here we have def example. We're creating a function called example. It accepts no parameters. And inside of this function, we're creating a variable called x, and it's taking on the value of 10. And then we are printing x to the console. On the next line, we're calling our function example. And then outside of that function, we are also trying to print x to the console. And if we try to do this, we're going to get an error. And it's going to tell us that x is not defined. And that's because x is a local variable to this function. The variable x did not exist before this function was created. We created it within this function. And the moment this function is done executing, when we call example and it runs through all the lines of code in this function, it says I'm done, it destroys those variables. So those local variables are destroyed. So on this line here, when we're trying to print x, we're getting an exception, and the program's going to tell us that x is not defined because this variable doesn't exist anymore. It actually only exists within this small local example of this function. So that is local scope. If you wanted a variable that you could manipulate within a function, which there are some reasons to do this, though it's typically advised to not manipulate global variables, you could create something called a global variable. So here you see in this code example, we're actually creating x equals 10, but it is outside of the scope of this function. We're creating it before we've defined the function, before we told the program that this function exists. And then we define our function. We say def example, and we don't recreate 10. We don't recreate x. We just use x. So we're going to print x to the screen here. And then we're going to call example. And it works just fine. And I have this in the examples notebook if you want to check this out. You can see that we call examples just fine, and it in fact does print x. And that's because x is not a local variable inside this function. It's actually referencing the global variable of x. This is a variable declared outside of the program, so the entire program, including the functions inside of that program, have access to that variable x. And they can do things, use that variable, and at times even manipulate that variable. So this can simplify tasks. However, overusing global variables can make it very challenging to debug programs. It can be really hard to maintain programs. It can get very messy. So keeping variables local to the extent that you can is usually typically advised unless there's a good reason to use a global variable. Again, pause for maybe 5-10 minutes and give this a shot here. A couple of things to note on practices or code that you might be seeing or working with as you're working with other programmers. First and foremost, of course, just as we do with variables, please use descriptive function names. Really try to define within the name what your function is intending to do, the intended focus of that function. Keep functions small and focused on one particular task. If it feels like it's getting really meaty and really complex and sticky, break it apart. Make it multiple functions. It's going to make it easier to test your code, to debug it, and to support and maintain it. Try to avoid side effects like modifying other global variables that you really don't need to. just to avoid the potential of debugging complex things in the future. And you may see these things called doc strings, which are these kind of fairly long blocks of text immediately after the function header, but before the body. And they'll start with 3 quotes here and end with 3 quotes, so that, because that's a multi-line comment in Python. And within these function, within these doc strings, it'll tell you what the function is supposed to do. It'll say, hey, this is a function. It greets the user by name. It takes in a parameter, which is the name of the user, and it'll tell you what it returns. You might see these types of things as you're looking at documentation for things like pandas or sklearn or other packages and libraries that you're using to help you code and write your code. And you might think, well, I can see the name of the function and I can see the parameters that it takes in. Why do I need all this textual information to tell me that? Well, sometimes the greet function may not be obvious. Are we greeting a user? Are we greeting a, what type of person are we greeting? So it helps build more context about what the function's actually doing. Parameter names can be ambiguous. So the doc strings help with the documentation in terms of making that code readable to other programmers, so other people understand your work and what you're trying to do and can leverage and build on that. Okay, and here is a recap slide. I'm going to pause for just a minute, ask if there are any questions. And if not, I'm going to move on to libraries and packages. I'm going to stop sharing for just a moment. Okay. Libraries and packages. Now that we understand the basic data types and we understand functions, a natural question might be, well, how do we use the wisdom of the people? How do we use the wisdom of the masses that exist on the internet to not reinvent the wheel? And how do we leverage other people's great minds and work and build on that work so that we're not always programming everything from scratch every single time? And this is one of the big advantages of the Python programming language and library, and that is all of the packages that exist within this, within the suite. So today we're going to talk about, well, we just talked about functions. Today is actually libraries and packages. So we're going to talk about what libraries and packages are. And particularly, we're going to focus on libraries and packages for exploratory data analysis, for performing EDA and performing visualization. So how do we read in data? How do we manipulate data? And how do we create visualizations on that data? The goal of this segment is to really analyze a data set using Python and create visualizations using Python. And then I'll also touch on a few other data science packages that we don't really have time to dive into in this in this duration of this class for Python, but they're a little more advanced concepts. And as you build on object-oriented programming, I would recommend that you start exploring them. It can be really useful. So packages and libraries. How do we use open source code? How do we use code built from other developers within the work that we are doing? So here's the setup. Imagine you're working for a e-commerce company and you're tasked with analyzing customer data and understanding things like sales trends and marketing strategies. And you have a data set that you've been given, and it's got thousands of rows with things like purchases and ages and locations and payment methods. And you've been asked to calculate something simple like the average purchase amount. And maybe there's a bunch of other statistics and reports that somebody wants generated as well. That can be a lot of code. If we start trying to do all of that manually, sorry, I think I have some of this in here. I'm creating the data set first. Here we are. If we start trying to do all of that manually, that can be a lot of code, and it's going to be very difficult to maintain. If we want to change one thing, you see here we're creating a function that calculates the mean, and we're getting the total, and we're getting the count, and then we're calculating the mean. So that's a lot. That's several lines of code. That's quite a bit of code to calculate the mean on something. And we're starting to introduce some potential for errors and making mistakes. This approach would be time consuming, it'd be error prone, it's inefficient, and it's a lot of work. It doesn't work well for large data sets. Instead, let's just leverage something called a package. Let's leverage a package called Pandas. Pandas can help us streamline a lot of this work. It can save time by ensuring that our code is efficient, easier to debug. A lot of these statistical algorithms are developed by experts on the internet. They've sort of been peer reviewed and checked and debugged, and we're minimizing our potential for error here by leveraging a package called Pandas. It's also optimized for performance, so it's going to work really well on large data sets, and it's going to make these tasks quicker for us to do and more manageable. So it's efficient and it's standardized. Many other people use the same library. We're all speaking the same language. We're using the same methodology. And ultimately, at the end of the day, it enables you to focus. If you leverage work created by other people, you can focus on the problem that you're trying to solve and not focus on reinventing the wheel. So a Python library, what is a library? A Python library is a collection of written code that provides reusable modules and functions for a specific task. Maybe we want to calculate the mean of something, or the median, or the mode. There's going to be particular tasks for doing those things that are developed and supported by libraries. They're designed to simplify these programming tasks, and they can range from data manipulation to visualization, which we're going to look at today, maybe even machine learning, which we're going to allude to or reference at least, and even web development as well. So they consist of a lot of different modules, which are typically Python files. They're based in Python files, classes, and variables, but ultimately it's pre-written code that can help you solve your specific problem and organized into segments of utility. So organized into modules and functions and classes that we can leverage. So it's reusable. Has task-specific solutions. It's quite easy to, typically a lot of work has gone into the thought process of designing these and how they're leveraged and used. So it's typically very easy to use, ultimately because it's community driven. So let's look at some of the file structure for a package. Go into So the file structure for a package here is a library is a collection of code, as we said, that simplifies the class. So you might have a folder at the top here called My Package. And within that package, you'll have something that's called in a init.py file. And that marks the directory as a package. Then you might have multiple Python files within that package. So we have module1.py, module2.py. Perhaps we even have some sub-packages. Every time you see an init.py file, that indicates that it is can be packaged in Python. And this is ultimately a structured way to organize the code. And it builds related functionality into one namespace. So maybe we want a machine learning package that can perform various machine learning operations together, score a model, train a model, fit a model. These are distributed as packages. Think of a library as a toolbox with a lot of different tools inside of the toolbox, and a package is a well-organized drawer system within that toolbox where each drawer holds related tools grouped together. So a package is a well-organized Python module, has that hierarchical structure, and it's essentially a collection of Python modules bundled together under a common namespace. I'll pause on this. You guys can read this slide, but here's some key differences between libraries and packages. And go ahead and pause for 5 to 10 minutes and try this. You try it. I am actually going to stop the recording and then restart the recording because I want to confirm that something worked real quick. So it'll come right back in.